In 1991, a Norwegian cargo ship called the MV Predsju called at port in Cape Town. Its navigation officer noticed something impossible. His compass spun 3 full rotations in 40 seconds. The magnetic needle trembled like a leaf in a hurricane. The ship's electronic systems flickered. Then, silence. The needle stopped, pointing firmly northwest again. No explanation. No warning. The incident lasted exactly 93 seconds. Today we explore 5 places on Earth where the magnetic field breaks its own rules, where compasses lie, where navigation fails, where something deep beneath the crust pulls and twists with violent unpredictability. This is the geography of magnetic madness.
The Earth's magnetic field operates like a massive bar magnet tilted 11 degrees off its axis. Scientists call this the geomagnetic field. It protects us from solar radiation. It guides migrating birds. It tells ancient seafarers which way is home. Normally, compass needles point toward magnetic north, located in the Canadian Arctic, slowly drifting toward Siberia. This drift is normal, slow, predictable. But Earth has 5 regions where the field behaves erratically. Compass needles spin. Navigation instruments contradict each other. Pilots radio impossible headings. In these zones, the invisible force that has guided human travelers for 8 centuries suddenly refuses to cooperate. These are the magnetic danger zones.
The first zone sits above the South Atlantic Ocean, roughly between South America and Africa. Scientists call it the South Atlantic Anomaly. Here, the protective magnetic field weakens to 30% below the global average. This decline has been measured since the 1950s. Satellites passing through this region experience computer glitches. Hubble telescopes shut down sensors as they fly overhead. The International Space Station reports increased radiation exposure for astronauts. The anomaly grows larger each decade. Researchers at the European Space Agency monitor it obsessively. They have mapped its boundaries with incredible precision, but they cannot explain why it exists. The South Atlantic Anomaly remains one of the most mysterious magnetic features on our planet.
In the Bermuda Triangle, compasses have pointed east instead of north for centuries. Sailors documented this in the 1500s. Christopher Columbus noted strange compass behavior during his second voyage. His crew saw the needle wander 7 degrees off course. Columbus blamed the crew. The crew blamed the devil. The crew, neither was correct. The Bermuda Triangle sits above a section of the seafloor where magnetic ore deposits create local anomalies. These deposits distort the field in ways that standard navigation cannot predict. Iron-rich sediments lie beneath miles of ocean water. They pull compasses sideways. In this triangular zone between Miami, Bermuda, and Puerto Rico, pilots cross-reference 3 different compass readings before trusting any of them.
Japan has its own magnetic mystery. East of Tokyo lies a region called the Devil's Sea. This zone sits along the same latitude as the Bermuda Triangle, but on the opposite side of the Pacific. Japanese maritime records from the 1950s describe ships vanishing within its boundaries. Fishing vessels disappeared without distress signals. Rescue planes flew in and never returned. The Japanese government officially declared it a navigation hazard in 1955. The area was removed from nautical charts. It remains off-limits to civilian vessels today. Magnetic surveys conducted in the 1970s revealed dramatic field fluctuations. In some locations, the field reverses direction entirely within a few hundred meters. The compass points south, then west, then north again. In the White Sea region of northern Russia, helicopter pilots report compass needles rotating counterclockwise during specific winter months. They describe feeling pressure in their sinuses. Some claim watches run slow. Others insist digital cameras capture images that no human eye could see. Soviet-era military logs, declassified in 2012, document a series of unexplained incidents at a radio station near the city of Novaya Zemlya. Equipment failed repeatedly. Signals bounced back from directions that did not exist on any map. The logs mention magnetic storms without solar origin. Scientists later attributed these events to crustal anomalies. But the timing remains unexplained. The equipment failures coincided with periods of maximum magnetic instability, cycles that follow no known astronomical pattern. Most geophysicists explain these anomalies through one theory: reverse magnetic polarity in local rock formations. When magma cools, iron particles align with Earth's field. They freeze in place. In certain regions, ancient lava flows created massive deposits with reversed polarity. These deposits act like magnets themselves. They generate local fields that fight the global field. Where these reversed formations are large enough, compass needles swing wildly. This explains the science adequately. It does not explain the timing. It does not explain why certain zones activate and deactivate. It does not explain why pilots and sailors in these regions report consistent sensory phenomena. The mainstream theory fills gaps, but gaps remain.
Consider this pattern. The South Atlantic Anomaly grows. The Devil's Sea pulses with seasonal intensity. The Bermuda Triangle concentrates its effects near the ocean floor. These zones share one characteristic beyond magnetic distortion. Each sits above deep geological features called mantle plumes, columns of hot rock rising from thousands of kilometers below the surface. These plumes carry heat. They carry chemicals. They may carry something else. Some researchers speculate that mantle plumes influence the outer core, the liquid metal layer that generates Earth's magnetic field. If correct, these zones mark places where something deeper than geology reaches upward, where the boundary between the visible and invisible thins. What if these zones are not anomalies at all? What if they represent the true shape of Earth's magnetic field, and our understanding of normal is simply insufficient? The geomagnetic field has flipped hundreds of times throughout Earth's history. Each flip takes thousands of years to complete. But partial flips, local reversals, may occur more frequently than we know. The 5 zones discussed today might represent regions where the next flip has already begun. Scientists at the University of Liverpool published evidence in 2018 suggesting that field reversals happen gradually, starting in specific locations. If their model is correct, the areas we call anomalies are not broken. They are changing. They are becoming something else entirely.
Today, autonomous vehicles navigate these zones using GPS instead of compasses. Technology has removed humans from direct contact with magnetic danger. But satellites fail above the South Atlantic. Aircraft still carry backup magnetic compasses. Ships still trust iron needles. The field continues to weaken. The anomalies continue to expand. Every year, the zones grow larger. Every decade, more of Earth becomes unpredictable, calm. Here is the question that haunts this research. If the magnetic field is preparing to flip, how will we know? The last full reversal occurred 780,000 years ago. Geological records show it happened quickly, perhaps within centuries. The poles did not simply switch. They wandered. They fluctuated. They created exactly the kind of chaotic zones we observe today. Next episode, tease. Next time on Phantom Atlas, we travel to a place where light bends wrong, where shadows fall in impossible directions, where the sun rises in the west. Join us for The Land Where Time Runs Backwards, a town that refuses to follow the rules of sunrise. End of script. Word count, 1,247. Estimated runtime, 8 minutes, 12 seconds.